So in this problem, we have to find value of x. So we have 5 raised to the power x minus 3 raised to the power x, and this is equals to 16. So we can find the solution by hit and trial method or by guess. So let us say if I say x is equals to 1 is a solution. So let us put this left hand side and see whether it is equal to right hand side or not. So we will have 5 raised to the power 1 minus 3 raised to the power 1, that is 5 minus 3, which is equals to 2. This is not equals to 16, that is right hand side. So this is not a solution. Let us try x is equals to 2. So if you have x is equals to 2, this means 5 raised to the power 2 minus 3 raised to the power 2, that is 25 minus 9, which is equals to 16, which is exactly equal to the right hand side. So this means I can say x is equals to 2 is a solution. So x is equals to 2 is a solution for this equation. Now we have to prove that there is only one solution. So in this case, we have to prove somehow that it has only one solution. It has only one solution. Now to prove this, first let us rearrange this term. So I will have 5 raised to the power x minus 3 raised to the power x is equals to 16. Let us take 3 raised to the power x that side. So we will have 5 raised to the power x is equals to 16 plus 3 raised to the power x. Now we can divide throughout by 5 raised to the power x, left hand side as well as right hand side. So I will have same expression I can rewrite. 5 raised to the power x divided by 5 raised to the power x is 1, and this divided by 16 by 5 raised to the power x plus 3 raised to the power x divided by 5 raised to the power x. You may remember a rule of exponent, that is a raised to the power m divided by b raised to the power m. This can be written as a by b raised to the power m. Now if I use this, then I will have 1 is equals to 16 divided by 5 raised to the power x plus 3 by 5 raised to the power x. I can rewrite this expression, that is 3 by 5 raised to the power x plus 16 by 5 raised to the power x is equals to 1. So this is the expression that I have. Now let us investigate this expression. Now we have two terms, basically two functions. So in this case, let us call this as function f1 and this as function f2. So this is f1 and this is f2. Now 3 by 5 is 0.6, a number smaller than 1. Now if you raise to the power x, if you increase the x, this value will be decreasing. So 0.6 raised to the power 2, 0.6 raised to the power 3, 0.6 raised to the power 9, 0.6 raised to the power 100. So as you increase the x, the value of this function will decrease. Similarly with negative x. If you increase, or you can say if you go more negative side, then this value will increase. This means this is a monotonically decreasing function. So let us try to see this. So what I have, so I have here x-axis and here I have y-axis. So this is my y-axis and this is my x-axis. Now if I want to plot this function f1, this means when x is equals to 0, 3 by 5 raised to the power 0, this means 1. So this means it passes through this point. Now as you increase x, this will decrease. Now if you go negative side, as you make x more negative, this will increase. So this means this function will be something like this. So this is a monotonically decreasing function. So this is a decreasing function. So this is a decreasing function. What about f2? So as you increase x, in this case 5 raised to the power x will increase, but 16 divided by 5 raised to the power x will decrease. So this means this is again a decreasing function. So this is also a decreasing function. Now when x is equals to 0, 5 raised to the power 0 is 1. So 16 by 5 raised to the power 0, that is basically 16. So you will have somewhere here. So this is 1 and let us say somewhere 16 is here. So this is again a monotonically decreasing function. So you will have something like this. So this is my function f1 and this is my function f2. So f1 plus f2 will lie somewhere here, something like this. So when x is equals to 0, what value will have? Basically this will go up because 16 plus 1 17. So f1 plus f2, so this is my f2, f1 plus f2 will be somewhere here, because when x is equals to 0, 16 plus 1, that is 17. So you will have this function is f1 plus f2. So this is 17 and this function is f1 plus f2. Now you see this will have only one solution because right hand side we have 1. So if I plot this y is equals to 1 line, so this means this line. So this y is equals to 1 line. So this is y is equals to 1. So now this line and this line will intersect at only one place. If I extend this or if I make the same diagram once again, so this is my x-axis and this is my f1 plus f2 function. So this is f1 plus f2 function and that is basically this one, 3 by 5 raised to the power x plus 16 divided by 5 raised to the power x, and this is my y is equals to 1 function. So this is my y is equals to 1. So these two functions will intersect at only one point, and this point is basically x is equals to 2. So this will intersect at only one point and that point is x equals to 2. So this proves that this equation will have only one solution and that solution is x is equals to 2. So I hope you like this video, and if you like, please share with your friends, subscribe to my channel, and I will see you in the next video. Thank you.